Assuming everybody's sitting comfortably with their glasses of wine or not, tonight is going to be a very straightforward overview of what you need to do to get your computer, stroke radio, stroke dongle or other pieces of equipment to detect the meteors as they burn up through the atmosphere and how we detect those. So it's reasonably straightforward. I've got a load of links on Facebook for other videos and links to other websites that will provide you with enough information to get you going. But obviously you'll get that tonight with me anyway. So it's absolutely straightforward. On the Facebook page, I've dumped an audio file which you can load with Spectrum Lab. So therefore you don't have to have any radio equipment to try it and then see initially how things look. So that's what we'll do tonight on my screen, which I'll share, and then you'll see how it works. Now, once we've gone that far and we've got some of your basic questions kind of out the way, we'll then listen to the radio and actually see if we can detect some live. But the problem is with what they call sporadic meteors, and I'll go through all this shortly, is the quietest time to detect them is surprisingly from about 6 o'clock to midnight. So we're now in the quietest time to actually spot sporadic meteors kind of live. But if we're lucky, you might see one or two. So if you like getting up early in the morning, that's the best time to see the sporadics. Because if you can imagine the Earth rotating through space, as it moves into clean space, it starts to hit all the rubbish going round in orbit. And that's what gives us a nice display of sporadics. Right, any questions initially? Hello, Chris. Chris, right?
Yeah, Joe, can you use a scanner?
Yes.
Right.
As long as it's got upper sideband. That's the mode that you need.
Yeah.
So provided it's got upper sideband, but we'll go through all this through the presentation.
Right.
We'll be looking at radio kit and aerials and the pros and cons and everything else.
It's a different
right. Now, I'm going to trust you to all mute yourselves so we don't get the washing machine and the toaster and the telly in the background. But if you've got an interesting question, please use the aforementioned method of catching my attention and then simply unmute yourself. So as I say, we don't have like 100 people on, so that's fine. So we can quite easily allow people to kind of chip in. Okay.
Joe, for those who don't know how to unmute themselves, you just press and hold the space bar down.
Right, did everybody hear that? Of course, you're all going to not be able to say yes, because you're all muted. So just use the space bar to unmute yourself. Yes, we can. Right, what am I going to do? I'm going to put the screen on now. So here we go. As I say, if you have any issues, just give me an appropriate shout. Right, I think we'll have this screen here. So hopefully you should all see my little screen there. Right, I've got a few people there. Right, I've just noticed one of the undocumented features, oh, it's okay, I'm working on it, is I can't necessarily see everybody in a video shot. So just unmute yourself if you want to chip in with 2 pence. So I'll pick a volunteer. Michael, can you see the main screen? Is it sharing okay?
Yes, it is.
Great. Right, okay. So this is a quick chat about how to detect meteors. And really it's reasonably straightforward. All you need to do, and I'm going to kind of give you a bit of an overview. So we'll give you a kick-off as to when this kind of thing all started. And then we'll get to the nitty-gritty, what it's all about and what you need to do, or not as the case may be. And then I'll show you a few things that I've captured over the years. But the first thing is a nice relaxing kind of 5-minute video, and providing I click on the right things, this should be reasonably smooth. But I'm just going to check my settings to make sure that is true. I just need to move that out of the way a little bit. And I just need to check some settings on the screen sharing, otherwise it'll all be kind of lumpy. So excuse this for a moment while I make sure there's a couple of parameters on. Okay, so you might need to turn the audio up a little bit for this, but hopefully you should see this video. Okay, here we go. He says.
Our look at meteors and comets begins right here on BBC4 with a special edition of The Sky at Night, Meteor Mania.
Good evening and welcome to a special edition of The Sky at Night. We're going to concentrate upon meteors, what they are, when to see them, and how to observe them. Well, we'll talk about the radio work later on, and we do have 2 radio astronomers here. But meanwhile, tonight it should be good. A cloudless sky and one of the best showers of the entire year, the Perseans. There's quite a gathering down here at my observatory in Sochi.
Now this is an antenna which tells you that we're doing something we haven't done on the Sky at Night for ages. If you watch the guy rope, this is radio astronomy. And with me are Andy Smith and Dave Entwistle, and they're already looking at the Perseans. So, Andy, what are you planning to do this evening?
Well, what we're hoping to do is to detect meteors through the use of radio. And this is an activity that can be done in cloudy conditions or in the daytime.
So we're already looking at the meteor shower right now.
Absolutely. It's not dark yet. The visual people can't see very much yet, but we're already seeing meteors.
Andy and David aren't trying to pick up the meteors directly. Instead, they're looking for reflected signals. The antennas in Patrick's garden are tuned to a French television station, and signals from its transmitter bounce off the trail left by the meteor in the atmosphere, allowing them to be detected down here in Selsey.
The atmosphere above us is actually illuminated by the transmitters from across Europe. So the television transmitters in Europe are already switched on, they're broadcasting and they're illuminating the atmosphere above us. As a meteor enters that atmosphere, it actually reflects a signal down to the aerials that we've got on the ground.
And we can actually listen to that. So if we turn on this equipment, then let's have a go. So this is live, what Belgian and French television transmission sounds like. And then what should we be listening for if a meteor goes ahead?
You hear a Doppler shift of the head of the meteor coming straight through the atmosphere. And that sounds like a rapidly descending tone. And sometimes, shortly after that, is a continuous tone which comes from the trail of the meteor.
So this is when you have a large meteor and it leaves behind particles on long.
The ionisation is strong enough to actually reflect that signal for a long time sometimes.
So have you picked any up so far this evening?
Yes, we have. If you have a look at the screen there, the vertical lines are actually reflections from the meteors.
All right.
Because we're operating over quite a short baseline between the transmitter and receiver, we're also seeing the curved reflections are from aircraft. The vertical lines are actually reflections from meteors.
So a couple there already, and presumably you can monitor the rate over the days leading up to the shower as well. Have you had a look in the last couple of days, Andy?
Yes, the meteor rates have been, I'd say, a little bit quiet compared to normal. But you'd normally expect to see the meteor rate increasing steadily night on night as the meteor shower increases.
Well, let's hope they pick up for later time. We'll come back and see how you're getting on. The importance of radio observations is that they can be used to monitor activity day and night, regardless of the weather. We already have the whistle of radio detections in the background, but the sun is setting, and so the visual observers are getting ready to capture the night's crop of meteors. Several times this evening I've looked up, seen a bright meteor, and then heard a whistling from the other end of the garden. And that whistling is coming from this antenna and its partner, which make up our radio astronomy experiment. So, let's see how David and Andy are getting on. It's now reasonably late. Perseus is high in the sky. So, what results have you got so far? Plenty of meteors, I can see that.
That's right, yeah. We've seen the rates gradually build from earlier on in the evening when the radiant was low down in the north. The rates have steadily built up as far as we can tell. But there was a prediction for enhanced rates at about 22:45, around about that time. And there seems to be some evidence, looking at it first glance, to support that view.
And this picks up filaments in the trail from the comet, so we're not just passing through a uniform cloud of dust.
That's right, yeah.
Andy, I heard a ping just then, so that was a meteor.
Yes, we just heard the Doppler shift from the head of a meteor plunging into the Earth's atmosphere.
And that one I can see on the screen is just a simple spike, but you've had some really spectacular ones this evening already.
Yes, we've had some quite long reflections which have lasted for several minutes.
Well, let's have a look at one of those, and you can see all this structure in it. You get the initial peak and then all of this. So what does that mean? I mean, what's that telling us, especially those? Oh, there's another one, and it sounds like some people saw that one as well, although I didn't. I was looking down. And you can hear there, that's going on for quite a long time.
Yes, so that was quite a strong trail on that meteor, which is continuing to reflect that signal.
So what does that tell us, that that's surviving? That was a particularly large meteor? Or?
If we would visually observed it, it could well have been quite a large fireball.
Well, it certainly sounded like some people saw something. There's still noise going on there. Is that another signal?
That's yet another meteor there, very strong one.
Fantastic.
Well, we've had a very satisfactory evening. We haven't had a meteor storm, didn't expect one, but we have seen plenty of meteors, and there are always meteors to be seen in the sky, shower or not. It's been great fun, and 2 points I think come out of it. First of all, we've done work tonight of real scientific value. Secondly, most of the people here are amateurs, and that shows again astronomy is a science where amateur and professional meet. And so now, from my garden of Chelsea, the sunrise not very far off, and meteor still in the sky above us. From here, good night.
And The Sky at Night is back next Sunday at 8:30 when we'll be looking at satellites. Back to tonight though, and we continue our exploration of the sky with a look at comets in A Comet's Tale.
Right, so make sure my microphone's on, which it is. Has anybody got any questions from what they've seen on the video? So just unmute yourself if you have. I'm just gonna stop the screen sharing, and then I can again change the parameters.
Hello, I've got a question.
Yes, just the £5 just remember that.
They've tuned into like French TV stations or whatever, and it's a common thing I've heard being done. Is it necessary to use European stations? Do we need that distance, or can we use Southern England or Scotland? What sort of distance do we need for a signal?
The bad news is, because that's quite an old video, there's no transmitters now. All the transmitters have moved frequency.
Okay.
So there is none that you can use nowadays. So what you do use is that frequency I gave you, which is the Graves French Air Defence radio, which I'll be talking about shortly. So that's what we're stuck with at the moment. There is another station, but it's a lot weaker in Belgium, but I'll talk about that very shortly. Right, okay, thank you very much.
Yes.
Yeah, if you just mute yourself, that's brilliant. Right, okay, so basically, well, it must be at least 10 years ago or more, when I got involved with, I spotted Andy on the program, and Andy's a radio ham like me, And when we had a brief chat, of course, I just turned round, and as you can probably tell, if I move the right way, I've got loads of radio kit in the background here. So literally all I did was tune to that frequency of the Graves transmitter and start hearing the pings. So within a few minutes, I was, you know, kind of hooked into spotting meteors. Right, okay, so moving on. This is, some of you might have already seen this picture, but the whole thing kicked off donkey's years ago. So it officially started allegedly in 1833.
Oh, sorry to interrupt. Do you want to do F5 to bring it up to full screen again?
Oh, yeah, sure. It's, right, okay, make sure it's on. Okay, is that back? Is that okay now?
Yeah, great, thanks.
Yeah,
that's fine.
Unfortunately, I'm on a separate screen, so I can't really tell the difference. Yeah, so anyway, basically, the story allegedly is there was basically a meteor strike in this French village, and the local astronomer professor got his young lad to go and investigate the meteorite landing, and that's when it officially was called a study of meteors or meteorites in 1833. So quite a long time ago. And it was the Leonids, which is obviously a very popular shower. And again, most of to varying degrees of success, but all the meteor showers can be detected by radio. Some are better than others. My favourites are the Quadrantids in January, but also the Orionids are actually quite cool as well. So if we jump forward a little bit, these guys here, Edward Appleton was the guy who got the Nobel Prize for discovering the ionosphere, and they were doing some tests in the Antarctic or Arctic, and I always get the two mixed up. And basically they were looking at the propagation of radio waves, and while they were doing their kind of experiments, they noticed that every time they saw a meteor burn up, they were getting a little blip on the radio, and that's when the kind of penny dropped that these things were related. So basically, in the early 1940s, they started. So this is just kind of after the development of radar and things. They started to do some kind of tests by literally firing radar signals up into the sky and watching them come back. But loosely, this diagram that's on at the moment is, if I can get an arrow to work over here. So this is, so if you can imagine this master station is Graves over here, and Graves is firing a VHF signal up into space. So VHF signals are highly charged, and normally they go straight through the ionosphere, just go straight through up into space, and they use it to track objects in space. So satellites, hammers, nuts and bolts, you name it. But what happens is a meteor will burn up, okay, and it will, as it kind of vaporizes, it will temporarily charge part of the ionosphere and make it so strong that it reflects the signal back to Earth. And that's what we detect. So we detect the returning signal from the French radar station in this case. And as I was saying a bit earlier, the much better stations were the TV transmitters on around about 60 megs, but they've all closed down now and moved to UHF. So as I say, that was a bit of a loss for us. So again, 1946 was another key kind of time when they started to. So this happened all over the world, using radars on different frequencies, all pointed up, to see if they can study the effect of the meteors burning up the atmosphere, which was quite interesting. So, a little, I mean, again, a lot of you are going to know this, but so just maybe for our younger member, just a bit of basics. So what is a meteoroid? Well, most of you have heard of asteroids. So an asteroid being a bigger lump of rock, a meteoroid being a smaller piece of rock. And essentially, in terms of meteoroids, we get about 100 tons hit the Earth's atmosphere. And the vast majority of that 100 tons is burnt up to give us our little firework display. But if you do a little bit of math, it works out at 33.6 billion pieces of or potential meteors burning up. Comets are just dirty snowballs. NASA have recently, 2 or 3 years ago, reclassified some of them. They were always a dirty snowball, but now they've identified asteroids which are flaking apart. So there's a slightly broader description for what a comet is these days, according to NASA. And really, the comets and asteroids are as you can read on the slide, are the main sources of the meteor showers, because basically they're just leaving the dust in orbit as they go around the sun. I mean, basically they're just leaving rubbish for the Earth to bump into. And of course, because we go around once a year, every year at the same time of year, we bump into the same rubbish up in space. And a bolide is normally a different kind of object, which is not kind of in the normal plane of the solar system. So it's on a bit of a hyperbolic trajectory. It is kind of entirely different, on a different kind of plane. So this is a little video of what you can imagine. So this will repeat. So again, you will get the lump of stuff in space like this. And then as it hits Earth's atmosphere, it's going to get worn away and heated up. And then if it's big enough and doesn't burn up all the way, it lands up on the deck. So potentially 3 different terms for the same object, depending on where it is. And here's some nice little videos, which are absolutely straightforward. So it's just to have a look at. So, whoops. So these are nice tails. I might have to start these with a mouse click. Or not. Come on. Oh, there's a little play button. Meanwhile, come on. Let's just go to the next one. I'm sure you've all seen comet's tails. There you go, that's a bit better. So that's just an asteroid. You can see no tail. I'll tell you what I will do just for a little bit of daftness. I'll see if Windows and PowerPoint will behave itself and go back a couple of slides. But goodness knows if it works or not. Right, let's see if this will work. Because it's always interesting to see an animated comet's tail. I'm afraid you just have to use your imagination. This did work earlier. But there you go. A certain law applies. This is another asteroid. And again, if you've got, if you can take some reasonable pictures, there's another one moving through. Again, you just simply take a sequence of images to create your own little video. And that's often how they detect kind of new asteroids, is literally by comparing stills and to see what's moving. Okay, so this is what I used to use many years ago. So this is a scanner. It's an old, as you can tell, it's an old, ancient, battered and bruised FRG 9600. This was about £500 in 1980 something. And it's actually tuned to one of the, well, that would be Iceland. At the time I used to use the Iceland transmitter on 62.251 megahertz. upper sideband. And that was absolutely great because on 62 megs or around about 60 megahertz, that gives you the more sensitive frequency. So if you imagine you've got the tiniest bit of stuff flying about hitting the ionosphere, that will generate a signal. Whereas on the VHF frequency, so here we are on the lower radio, so this is tuned to graves. You need a bigger meteor to burn up to produce a signal. So in effect, the television transmitters on that frequency of 62 megs was much more sensitive. And funnily enough, the one in Belgium at Ypres, or Yves, however you pronounce it, is on 50 megahertz, which again is a very sensitive frequency, but it's only got 150 watts power output. So it's very low power compared to the Graves transmitter, which is in gigawatts. So that's what you need. So you need a radio, and you can see some wires here. So this is the audio coming out. And of course, the audio goes into your computer. Now, that's Bernie Lovell, who famously spotted Sputnik just before I was born. Honestly, I mean, I know sort of Ken and Michael have a very good memory of this, but I didn't exist.
I watched it going over.
So this is a little video or a little illustration of the Graves radar. So this is what it's designed to do. It's kind of a pulse transmitter, and it's got different aerial arrays that point in different directions. And again, the maths works out where the object is, its speed, height, and everything else. So this is how the tracking works. So all we do is we utilize that big fat transmitter down in Graves and receive the reflections from that transmitter. So this is what I've used. So again, because I'm a radio ham, I actually had one of these little portable aerials. So again, I just dug it out the loft, plugged it in my radio, and away I went. So you can pick these up for 20, 30 quid on eBay nowadays. Or of course, if you're handy and you've got a source of stiff wire or aluminium, your brake piping, you can make your own antennas. It's not a massively complex thing to do if you're handy and you've got a few, as I say, bits of material. And this is really the process of what you do. So you capture your radio signal, you get the audio signal out of your radio. So again, that's through your speaker output or your monitor output on your back of your radio, and then you plug it into your microphone or line input on your PC. But of course, nowadays, for the more up-to-date members amongst us, like young Kenneth and the Harris family, you can have these things called SDRs, which are software-defined radios, which are little dongles, not big radios. It's literally, I haven't got my fun cube to hand, but you're looking at something like that. A bit like a memory stick. And you stick an aerial on the end, wire connected up to your aerial, and then it just becomes a USB audio source on your computer, which is slightly easier to deal with. And then you start up Spectrum Lab, and then basically you tell Spectrum Lab that you want to listen to, because you've got a number of ports on your PC, and you just identify what you want to listen to. So for example, I've got a mixer. I've also got a microphone input. So what I've currently got configured, or will have configured shortly when I run Spectrum Lab, is I'll tell it to use my microphone. Now, I don't know whether you can see it or not, but this cable here, this cable here is plugged into my microphone. So from this radio into my microphone socket on the laptop. Now, just a little provisor, the more modern laptops have a 4-pin plug, because normally, well, once upon a time, you used to have a separate microphone and the ear socket, but on the more modern laptops, they're combined. So you've just make sure you buy the right type of socket in order to connect up to your laptop. And really, that's it. Now, you're going to say, well, why is the moon there? Even though I've been a radio amateur for nearly 40 years, the most distant signal I've ever received is from the Grace transmitter in France. But of course, that's when it's bounced off the moon and come back. So one of the things that I spotted, and again, I didn't know this until I kind of researched it a little bit, because I noticed by chance when I was kind of right into this, I used to have it on virtually every day in the office, running on a PC, and then I noticed this permanent trace on the screen, which I thought was a bit strange, rather than the little pulses that you normally see. And I happened to notice that the moon was up during the daytime, and it didn't take long to find on the internet that the Grace transmitter is so strong it'll bounce signals off the moon without a problem. So when the moon is in the right place for you, you will actually receive signals from the French transmitter via the moon, which gives you your 500,000 miles round trip, which is quite cool. The other thing in the spot is the International Space Station, which again is only generally up for a few seconds because it's moving at quite a pace. And you can also see some of the, or detect some of the larger satellites. But it's something that I haven't done because, again, you've just got to be in the right place at the right time. So, everybody happy so far? We're not going too fast, too complicated? Excellent. Okay, so we'll have
a question.
Yes, Chris.
A question. One of your earlier slides showed the master station or the Grace transmitter unit, and it said the maximum distance to the receiver was 1,200 kilometers, was it, or miles? I can't remember whether it was one or the other.
Yeah.
Is there a minimum distance? Do you have to be a minimum distance away from it for it to work?
Well, generally, I think from what I've gleaned over time, it's around about 600 miles. Between 600 and 1,200 miles is a kind of optimal kind of distance, because of you've got to allow the signal to go up 60 miles and then get reflected down.
Which would exclude anything in the UK, because there's nothing 600 miles from us that's still in the UK.
Yeah, well, that's the kind of general kind of rule of thumb. But basically, the closer you are to the transmitter, the stronger the signals will appear to be. So really, it's kind of optimal distance. And again, that could be kilometers rather than miles. But
just to say, Joe, there's a guy up at Ullapool who's got a live website to this, and he's right up in the Orkneys, so that's quite a distance for him.
Yeah. I mean, there's people on the south coast. I mean, obviously, Patrick's just across the coast.
Yeah.
And that's what they were using. The TV transmitters. And again, in those days, the TV transmitters were a lot more sensitive, or the ability to receive them on that frequency is far easier. Right. So if we have a look on the screen, so this is the basic look at Spectrum Lab. So what you can see along the top is so what Spectrum Lab is an audio analyzer, essentially. So it analyzes audio signals. So when we listen to that whistle on our radio, basically Spectrum Lab is displaying what that whistle looks like. But it can do it in a detailed way. So we can measure the frequency, we can measure the amplitude of the signal, which then we can infer certain information about the meteor. So a kind of straightforward one would be, if it's a big signal, it's going to be in proportion, it's going to be a bigger meteor than other ones. For example, the other thing that we'll see going across the screen, can you see that mouse pointer okay? Yeah? Good.
Yes, I can.
Okay, so if the signal goes across the screen, that means it's changing in frequency. And if it changes in frequency a lot, that what we call Doppler shift. and Doppler shift indicates speed. So when we hear a change in frequency, we'll see a line go across here, and that will demonstrate to us that it's a fast meteor. The sporadic meteors are quite slow. They're only coming in at about 25,000 miles an hour. So it's not that fast. And they just appear as a dot. So as they hit the Earth's atmosphere, they virtually stop dead because they don't have a lot of velocity. So compared with Perseids, which will travel maybe 160,000 miles an hour. So basically, when we start receiving so we'll load our test file up shortly. But again, I'll just whip through some of these. So this is a little, see this little area here. So I just did an audio test. I just whistled. And you can see how that's got a width to it. And again, you can see it kind of started off at, say, 1500 hertz and went to, what, maybe 1900 hertz. So that was just the whistle. So that was me changing the frequency just with a simple whistle. Now these are some captures. So these are sporadics. So you can see there's no, I mean, this is on a side view. So okay, so I've turned it around a bit. But in essence, they just look like little spots. Okay, so there's no vertical element in this case because I've turned it around to indicate speed. Okay, so these are just the sporadic ones. These you'll get every single day of the year, all the time. Now this is a slightly different one. So you can see this looks a bit bigger, and you can see all these little flashes going across, which is meant, so these are the pulses from the radar. So this meteor, when it hit, made the ionosphere last for maybe 30 seconds or so. So I think it's every 2 seconds it pulses, or every 1 second it'll pulse. So that ionosphere was already corrected, sort of in place. And the pulse just reflected straight back every time. So that's what all these horizontal lines are. So these are all the pulses from the radar. The other thing you can infer from a broad signal, so it's quite wide, okay, is upper atmosphere disturbance. So generally the upper atmosphere is a bit disturbed from that. And let me just, so here's another, so you can see on this center display here, again, that's been blown all over the shop. Okay, so when it gets blown, so it's a physical thing. So when it's blown apart, you're able to get multiple reflections. And again, you get a different type of image. So if you compare it with this one here.
Can I ask a question? Does the position of the jet stream influence that at all?
How high is the jet stream?
Pass. Anybody know?
Well, if it's very high up, yes, it will. But generally, you know, most of the times things are I mean, it's one of those things. It's quite fascinating when you get into it, which is quite good. So again, you can see this is on a slightly different time base. So one of the things that you need to remember about Spectrum Lab is it's very configurable. You can tune it, you know, you can twiddle with it, you can do all kinds of things with it to display, you know, more things that you're interested in. So you can see this is on a fast trace. So you can see the gaps between the pulses are a little bit bigger. But you see this is the amplitude of the signal. So this is a nice big one. Compared with these other ones, if you compare the one in the middle, you can see that's just a little bit. And again, this one over here, it's just, so actually if you measure, if I can stare, that's going up to minus 60 dB. Whereas this one's approaching minus 30. So you're working backwards in dBs. The fewer dBs, the stronger the signal, up to 0. Right, so, okay, so here we see what Yeoman was mentioning earlier about if we saw a vertical one on this display. So this is a fast one. And you can see this kind of pyramid on its side here. So the signal started, you can see just over here, kind of this is the sensitive part where it, if you like, as it burned up. and then obviously it just tails off in frequency. So we know this is a fast meteor. Okay, it's not just a single little splodge. You know, it's a big signal, and it's wide. So we know that's a fast one. So again, if we're observing in showers, we'd normally look for the speedy meteors. So that's how we would tell. Now this is a one that's left a trail for a long time, and if I can stare at my screen, that 58:35. So that's 30 seconds. So that's about 3.5 minutes long. Okay, and again, you can see the pulses. Are they minutes or 30 seconds? Oh, 5 seconds. So it's 5, 10, 25, 30. So that's 30 seconds at least, and it's obviously still going. So again, when that meteor burned up, it left.
Is that just one item that's burning?
Charged. So that's just one.
Okay.
And again, this, we're only talking about something about the size of a, well, smaller than a pea. I mean, they are quite tiny, these things, when they burn up. Another one. So again, these are kind of just, you know, average kind of stuff. It's the showers that are interesting because you don't know what you're going to get at the end of the day. Right. So I'm going to put the video back on because this is a video to listen to. Now, it's got a surprise in it if you can turn your volume up and your bass up. Because one of the things that obviously happens, I mean, we detected this by radio, but you can imagine being outside and one whistles past. So this video I'm going to show you is of a guy in Chelyabinsk. So that's a bit of a clue for you. And basically, he's working away, and the Chelyabinsk meteor goes past, and he digs his phone out of his pocket and shows the trail. But at this point, the shock wave hasn't hit him when it exploded. So if you don't like large or loud sounds, put your fingers in your ears. Okay, so I'm just going to stop this share just so I can set it up to have sound and optimize. Okay, so here we go.
Could you put it in full screen?
So basically that's the, if I share this properly, and that's the hole that left. So essentially it punched, not a very big hole, through a lake in Chelyabinsk. And of course the Russians, when they lifted it out, they put a chain around the middle, unceremoniously just humped the thing out. And when they dumped it on the ground, it actually broke in half because they just had literally a rusty chain around the middle, allegedly. But they did actually allegedly stick it back together. And that's the bit in the museum. So so that is that. So any questions on that so far? I'll just shut that down. Are we all happy? And then we'll go on to the more interesting stuff.
One thing I was going to ask you, when you mentioned the International Space Station and larger satellites, I mean, everyone's worrying about the optical effect of this Skynet system from Elon Musk. Is that going to have a similar effect on radio astronomy?
Well, potentially, because it's going to get in the way. So it just depends. So if you've got a sort of looking at your proper radio astronomy, rather than this kind of this toy stuff that we're doing, detecting meteors, which is very simple, straightforward. Yes, it's going to get in the way, isn't it? So radio waves. I'm not sure where that sound's coming from. That must be, yeah. That must be it's Ken in Peterlee. So I've just muted you, Ken. So yeah, I mean, it's anything that gets in the way, it's going to spoil the fun to a degree. But yeah, I mean, if you're doing a PhD in astronomy and radio astronomy, and you've got these flaming things getting in the way of your dish, yes, it's going to be a bit of an annoyance, to say the least. Right. Okay. Well, if I've got no other questions,
can I ask a question, please? If you're bouncing this from France, are you taking the reflection, and you don't know where that meteor is going to be, or is this local to what you've got your aerial?
Yeah. So it's, if you imagine somewhere between where you are and France is. So if you imagine a straight line between here and France.
Yep.
And you imagine typically about halfway, okay, between 60 miles up, and make a bit of a triangle, a bit like that diagram. That's the kind of area of atmosphere that you can study.
Right.
Because anything closer to France will be reflected short of you. Anything further away will be reflected over the top of you. So there is a kind of optimum distance. But the thing is, you'll always detect something at the end of the day. It's just, if you're in an ideal position, you can detect more, but you can always detect something. So it's one of the reasons, again, I had multiple aerials up on different receivers. And one of the things that I discovered with my directional antenna pointed at France, I didn't get all the signals as I would have expected. So I've had signals reflected back to me in a broader scope. So I actually use an omnidirectional aerial these days. I mean, I don't have me big beam up now, but as I'm doing these things kind of casually every now and again, it's more than adequate for what I want to do nowadays.
Right, so if you get the pings coming, you just can't look out the sky and see it happening where you are. It could be anywhere.
Well, basically, if you get a ping, if you look towards France, the trouble is it's likely to be in effect very low because you're looking beyond the Earth's curvature.
I understand.
So basically, you would be trying to look, almost level with the Earth, so at the horizon level. But the other big thing, which I haven't mentioned yet, is the other big beauty of radio astronomy is it will detect meteors that you can't see. So even if you were able to see, the point where it burned up, you wouldn't really detect it, because it can, the radio is far more sensitive than your eyes in terms of detecting these things.
Right.
Marvelous. Right. Has anybody downloaded Spectrum Lab and stuck it on the machine?
Yes.
Yes.
I have.
Yeah. We have a couple.
Yeah.
Right. Okay. So what we'll do, so this will be, if you've already had a play, this should be hopefully familiar. I'm just going to pull it up on the other screen. Oh, let's get rid of that. Right. So again, this is the kind of, as you can see, I'm detecting all kinds of rubbish. So it's probably got picking up a bit of my microphone. Now I need to share the screen. Or are you still seeing it? Can you see Spectrum Labs?
No, it's small in the corner.
All right, okay. Let me just get that up to full screen then.
We've got it.
Right, okay.
It was full screen for me.
It was full screen for me as well.
All right, well,
Yeah.
hopefully that's back to full screen then.
Yeah, that's fine.
Right, okay. So essentially, these are the steps that you would normally go through if you had a kind of fresh install. If you go into options and then opened up audio settings, and again, I'll just pull this onto here. Now I'm going to have to squint at this because this is on my laptop screen. So you can see here where we've got our input device. And I'm just going to use the drop down. Okay, so we've got various things here that we can select. So these are our input things that we can select. Now, because, and I'll backtrack a little bit, because I said we'll use a test file, we're going to go to File, and then if you look down here, you will see an audio file playlist. So if you click on that, it will then open a box, which I've probably got on this side of the screen. There it is, hidden by all kinds of junk. So what you'll have is, so if you click on the folder, you can then look for the audio file that I put on Facebook. And then you can obviously just download it to your machine. And that's what I've done. Now, I've just got a 5-minute one there. So I'm just going to load that 5-minute one. Click on open. And then there's a little play icon here. So these are just like the standard kind of controls that you have on most of the software kind of audio drivers. So I'm going to click on play. And then what you're going to see, hopefully, is some blips coming down the screen. Now, what I'm about to show you is the crux. And this took me quite a while. So you can see there's some things coming in here. Now, over on the left-hand side, there's a B and a C, brightness and contrast. You need to balance these out for your own eyes. So you can make things very bright or very high in contrast or very faded away. So you can see the signal actually disappears depending on if you have it very bright or very dark. If it's too bright or too dark, you ain't going to see it. If there's too much contrast or not enough, you're not going to see it. So you basically play with these until you get something that you're happy with in terms. So I think you all should be able to see that okay. Yeah, see your thumbs up if you can see. Yes, we've got a none head. Brilliant.
Fine.
Okay. Now, because this is a test file, these are going to come thick and fast about every few seconds. Okay. But you can do an awful lot with this software. Now, the first thing that we want to do is to be able to listen to the audio. So what we need to do is go into options, then into audio settings, and then this area here, which is I/O input adjustment. And I'm just going to bring this screen up here, and it'll produce this little box here. And this is almost like a little logical circuit diagram of what happens to the signal. So the signal comes in here, and what we're going to do is we're going to bypass the filter, and we're going to come out at this end. And what we're going to do is enable this DAC, which is a digital to analog converter. Now, I'm just going to make sure, can you hear sounds now? Yes, no sounds, right? Okay, let me just stop sharing. And then I'll just enable it. Share sound. Screen 2, share. Right, so hopefully you should hear some hisses now. Yes, brilliant. Okay, so you need to turn that on. I will mention this is a little volume control here. Makes it louder and not louder, but you don't want it too loud because it just gets distorted. So again, just something which is reasonably comfortable for you. And then you can hear the whistles.
Joe, how did you switch that on from the configuration box?
Okay, so it's in this little option here where it says IQ input adjustment. So that's where it is. Again, there's loads of tutorials that you can show you on the web, but essentially, see, that's quite a loud one. So you just go into options, audio settings, and then I/O input adjustment.
Right.
So now we can hear the sounds. This is because this is a default configuration. It's not particularly brilliant for what we want. So I want to get rid of some of these lines. In fact, one thing I'll show you, which is nice and easy to do. So if we go to options, we come down to number 4. That's my video run out. So I'm just going to go to option 4, and you can see this 3D display, 3D spectrum display. Just going to turn that on and then apply it, and then close the window. And now I'm just going to restart that that file. So audio file playlist. Again, we've got to find out where Windows has put it. Where have you gone, Windows? Let me just put that back up. File, audio file playlist. This is always a problem when you're dealing with multiple screens. There it is, hiding underneath my Zoom screen. Okay, so we're going to start that again. From play. And now what you'll see is a wider kind of display. And let me just make sure I've got some sound still. Right, I haven't got any sound, but can you see that display there?
Oh yeah.
Okay, so that's a nice easy, yeah, I'm just gonna, so this is a much easier method. If I slide that along a bit. Because you don't need to configure anything. You just click on the 3D option. So this basically shows you the signal flow, if you like, so it even looks like a flow in 3D. And then you've got these peaks which are popping up, which are the meteors you're detecting. So this is quite a nice display, you know, and it makes it nice and clear as well. So let me just go back. So again, that's within part 4, 3D spectrum. So I'll just turn that off. Go back to our display. And what I'm going to do is I'm just going to restart Spectrum Lab, because sometimes it does act the good. Then things will stop working for no kind of good reason. So we'll just kick it off again. Okay, there's our sound back, which is good. And again, I'm just going to load another audio file. You can still hear the sound, yeah? Yeah, great. So, I'll go file playlist. I'm going to load a bigger one because it's, so this is the one that's actually on Facebook. And what I'm going to do is show you how to set up this screen. So if you notice, this is there's no kind of waveform thing at the top. So let's just turn it on. There's a frequency grid, we'll get that off. And we'll turn the waterfall on. And the spectrum graph. So you can see this is where the, generally I tend to tune it for around about a kilohertz for 1000 there, because that's kind of quite easy on the ear. There you go, turn it over a little bit. So we've got those coming in. Now if you notice up here, so that was a fast one. You can see how that looks a little bit longer. Now you've got pluses and minuses in here on this area of the screen, which will let you zoom in to see more of the waveform. Okay, and again, if you use the minus, you can make it quite narrow. Now another clever thing you can do, because you don't need the whole width of the screen, as you can see, you can actually turn this around 90 degrees. Okay, so now we've got it coming in along the side. So let's suppose you wanted to, there's a little option here for using multiple strips, and you can configure these within the options. So again, if you go to your spectrum display settings, so this option here for multi-strip width, so we're going to make that say 300, and then apply that. So what we'll now see in effect, and I'm just going to centralize this, just lift that up a bit, so we'll get those in the middle, and I'm going to make that a little bit darker, so it's a bit easier to see. Now once you get to the end of the screen, I'll just tweak this a little bit more. So once you get to the end here, it's going to start on the next layer down. So if you've got bits and pieces to do in the house, you can let this run, and then basically, rather than just last for a screen having 30 seconds or so, you're going to get multiple traces. Now again, using the options and the display settings, you can actually put some lines on here. So, okay, I'm going to enable 60 seconds and apply that. So you're going to get like this time stamp. So every 60 seconds, it's going to create a line. So you can see we've got nearly 2 minutes on this central line here. So that'll be another 2 minutes on the top. and then there'll be another 2 minutes on the bottom. So if you make that narrower, you can put more strips in and therefore record it longer. The other thing you can do is speed up the display or slow it down. So that was a slightly noisier one, right, just coming in. So again, these are all, so again, you can use the test recording and run this through multiple times and then just configure it for the way you would like it, which is quite cool. Okay, all happy so far? The other thing, so I'll just put this back, I'll revert this back to the normal screen, which is what I kindly start with. Okay, and get rid of that. So that's our standard screen. So again, remember the 3D display, option 4. Okay, so that's your 3D one. So that's the easiest thing to configure. And again, this is just all the noise floor, all these tiny little bits. This is just average noise. And there's a nice easy meteor for you to see. So the taller it is, you notice it changes colour, the bigger the signal. So that's the amplitude. The higher the mountain, the bigger the signal. Now the other display you can do with this, which is a little bit trickier, but again I'll show you it, and then you can make judgments whether you want to use it or not. So we'll get rid of that. And then we're going to go to an option where it says Windows. And then, all right, I'm going to get rid of this one. Ken sent me a configuration. And I'm just going to put this one to bed. And I'll see if I'm going to get a fresh version. Which is here. So basically Spectrum Lab is a complicated piece of software. It's a bit of programming. So what we can do is actually, if I get this over, and I'm just going to start me audio list, and it pops up. There it is.
We're getting an echo, Joe.
Yeah, you will once I get this off. Play. Right, hopefully the echo is gone. So again, we've just got our display back. Just move that out of the way. And I'm going to bring this plot window. So what the software does is it has variables, and this is one of the variables here. It's called peak amplitude. So it just measures the signal all the time, and so it's just bubbling away. And then when it sees a big signal, it puts a peak in. So one of the nice things you can do with that facility is plot it. So you can see on here, this is all the noise. And if I just pull this down a bit. So every time you get a bigger bit, it indicates a meteor. So again, you can adjust this for speed, so you may go faster or slower. So you can either count more meteors over a time base or fewer. So if you sped this up, you would see more shape within the display. So again, you can just simply count the peaks and go like 1, 2, 3, 4, 5, 6, 7, 8. But because this is an edited sound file, you're going to get them about every 5 seconds, because this is what I created in order to demonstrate to people how things operate. So that's a plot file. Now again, if you're going to do a demonstration for the public and you had a couple of big screens, you would obviously just have your plotter on one You could have your 3D display on another and this display on a third. But that's the plot display, which again you can have a bit of a play with. But I find most people enjoy the 3D one. And again, I'll just put that back up. And then we'll just look for a minute in how it represents fast ones and slow ones. So you've got time going this direction and Doppler shift or frequency range going in this direction. So if you see a fast meteor, it's going to look across this kind of direction. And if it's just a normal sporadic with no speed, it'll just be in this plane. So what we'll do is we'll just look at the display for a moment. So you can see this is all going in this direction. So that these are just normal sporadics or meteors without any speed on them. So what we're going to do is, and also we're using our ears as well. So if we hear that frequency change, that should be represented by going kind of top left to bottom right. So these are all sporadics at the moment. And twiddle your thumbs. And wait for a fast one. Right, so while we're waiting, any questions?
Sure.
Yeah.
Does the government require any regulations to use this equipment?
What equipment?
Well, what you're using now.
No, it's as long as you don't admit to the French Air Force that you're using their radar, I don't think they mind.
Well, you're just listening, aren't you? You're not transmitting, you're just receiving.
Right.
The licenses are all needed if you want to transmit.
Technically, the Wireless Telegraphy Act stipulates that you should not acknowledge the reception of a signal that you're not licensed to receive. But essentially, no, nobody's interested. I mean, everybody listens to all kinds of stuff nowadays, but nobody pays attention unless you're from MI5. So if you notice this one here, which I missed, this one's got the width to it, so this would have been a fast one just going off the screen. And again, we've got a few more sporadics coming in here. Now, the other transmitter in Belgium is you've got to build a decent aerial. You've got to have an aerial is a bit like the old-fashioned. So, see this one here is wide. It's got a width, and you heard the Doppler shift in the whistle. So this is a fast one. So this one would be associated with a shower. And obviously this is still the quadrantids that were 2014 quadrantids. So this particular one we could definitely identify as we have the evidence in its Doppler shift right in front of us. Yeah, so if you remember the old ancient black aerials, you know, the big TV aerials, you need to make in effect a big old TV aerial and point it at Belgium. And you can receive, I've received signals from it, but you don't get that many. So you've got to be kind of very keen to track them. But again, you can use the software, which, and leave, you know, if you leave your PC on for a long time, you can actually count all the hits using some software. I mean, Ken's familiar, and I think he's got a configuration file that you can use with Spectrum Lab that will count the number of meteors. It also measures how strong they are, and then that basically puts it into a file which can then get uploaded onto the ARMOB website. And again, you can just look at that in your browser and you'll see there's people all over the world put data relating to detecting meteors by radio, which is quite cool. Now, essentially, that's kind of it, more or less, for a general kind of overview into how easy it is to do. I mean, obviously, some of the bits I've showed you, the software is a bit complicated, especially if you're not familiar. But again, using this 3D option, it's really straightforward because you can visually see what's going on. You know, you're not having to set up the brightness and the contrast and all this kind of stuff. It's kind of already done for you. So you can just look at the screen and say, look, there's 4 meteors. You know, quite straightforwardly.
What kind which SPR would you recommend?
I'm sorry, you're a bit broken up there. Let me just stop this for a minute. Right, who was that?
What make of SDR would you recommend?
Oh, there's loads of different ones. I mean, some of the cheapies work absolutely fine. You know, 20, 30 quid.
I've just been looking on Amazon. There's some round about the 30 quid mark.
Yeah, I mean, I've got a Fun Cube which was £150 because I use that because it's got a much better front end than the cheap ones, so it can reject interference far better than the cheaper ones. But
We
also,
use a new
so once you've got a decent one, you can reject signals. It's far better. The front end's a lot sharper. You can also use SDRs for detecting satellites and things. So you can download data from the FunCube satellites. So you look at some of the thermometry data, the temperatures and all kinds of things. So it's quite useful to get into some of the SDR. I do have another SDR receiver somewhere, which I haven't got to hand. But that was about £250, which is a dual mode one. But that lets me, obviously I'm a radio ham, so I need a kind of decent bit of kit.
I'd just like to say, Joe, to the people watching and the club members that we have got the actual setup at the club with the FunCube dongle and the aerial, which is what I made of the Sky at Night magazine, but it works. We've tried it. So it's all there for everybody to go down once we're open, that is, but have a bash and try everything out.
Yeah, absolutely. So what I'm going to do now is I'm just going to switch this over to an audio input. I'm going to put this on my microphone and then click apply and then click on start. Now hopefully this is not too loud and we don't all jump.
Oh, you broke it.
I'm just sneaking the volume up. This is a bit sensitive, this one. I'll just see if I can turn that down a little bit. The other thing that you can do is use these arrow keys either side. Yeah, that's all it was. It was a lot of electrical noise. So while you're looking at this screen now, this is live. Okay, so don't expect to see very much because it's kind of evening time. So so we might be watching this for 5 minutes, 10 minutes and not see a thing. So don't be too surprised. And what I am going to do is I'm just going to go into those audio options and turn it down a bit because that's quite loud. So let me get into the audio options, into the I/O adjustment, and then go into here and then turn that down a notch or two. That's better because mainly we're just going to have a look at the display. And for the youngster, that's Mr. Harris Jr. You keep your eye on that screen and tell us, because I'll not be looking at it. Tell us if anything interesting pops up. Again, you might just hear a whistle. Yeah.
Got a couple of questions for you. I've been using some equipment that Ken loaned for me to try and get going. About the aerial. I've got the aerial that Ken actually made. I've mounted it on the top of my shed.
Yeah.
Now, I've got it up, I've got it inclined up about 10 degrees. The aerial is horizontal and I'm lining it up approximately south-southeast towards France. I mean, would that be good enough?
Yeah, absolutely fine.
But the other thing I've learned is that the dongle that I'm using, I have to make sure that I put an extension to keep the dongle away from my laptop.
Yes.
Because it actually does make a difference.
That's right. So this is one of the reasons I've got the Fun Cube, because the Fun Cube rejects interference. It's the RF stages have got a bit more protection in it.
It's taken me quite some time to discover that, by the way.
Yeah. Well, it's a bugger because, as I say, and it's also the same for some quality of the USB leads are not necessarily brilliant.
The only other thing, the length of cabling from, like for instance, I sit in my conservatory and I've run a cable out to my shed. Is there any distance that one should not go over?
Yes, anything more than an inch, really. So the longer the aerial cable,
yeah,
the more loss you get. But if you're using a high quality cable, obviously you have less loss.
Right.
But generally what you would do if you had a long distance is you would use a long USB cable.
Yeah.
So it's better to use USB cables to your laptop, and then you keep keeping all the interference from your laptop or other electrical equipment away from the receiver.
The answer is for me to move into my shed. Yes.
Well, it depends where you keep your tinnies, really.
Well, I've got my cable on my chimney, so it stretches from there downside the house, along my back garden, my shed. I think it's approximately 50 metres. But I use a decent aerial and a high coaxial cable, and I'm pretty well getting some good hits. Could be better.
Right.
Yeah. So again, you've got to use, well, technically for receive you can use 75 ohm or 50 ohm, but 50 ohm generally better. But if you get some of the better quality amateur radio stuff, that is usually better at rejecting interference, because again, the idea is the signal that you pick up with the aerial is what you want to go into the pipe, which is your coax, and you don't want that to be interfered with until it kind of gets to the computer end and gets processed. So ideally, the better shielding you have throughout the system means that little bit of a signal that you get will be hopefully reflected in a little bit of a display. So you can see we've been on this display now for about 5 minutes and not a squeak.
Okay.
So I'm just having a look on the receiver, and yes, because I mean I have monitored before when I've been on the wrong frequency and I've had an attenuator switched in and various other things. And the other thing you should know is sometimes the Graves transmitter actually goes into maintenance mode, so they turn it off, and because it's on a multiple segments or multiple aerial arrays, sometimes I guess they must turn off the array that is helpful for us. Because again, you look on the internet and you'll get some people putting on the forum that, I've never had a Meteor for 2 days, and somebody will say that, oh, well, it's, neither have I, it's been off for 2 or 3 days.
Is that the cosmic microwave background, basically?
Noise,
the noise
yeah.
you're getting?
Yeah, it's just noise.
We might get cut off because the battery's getting low and it's not charging properly.
Oh, right. So, as you can see, nothing displayed on, so we haven't detected anything live, but we would have by now normally, even at this time of night. So I'm guessing Graves must be turned off.
I'll tell you one interesting thing. Listen to that white noise has switched my tinnitus off.
Marvellous. Right. So I think we'll just have a bit of an open forum now, so everybody can see everybody else, and have a general chin wag.
Ready-made aerials.
Yeah.
Where's the best place to buy a ready-made aerial?
Well, what you have to, in terms of aerial, you've got to think of what you want to do with it, because there's two main types of aerial.
Yep.
There's omnidirectional aerials, which are the things that you often see at the taxi place. Now, can you believe that? I'm just getting a whistle on me.
I can hear it.
On my screen, but I think that's a bit of interference. I mean, obviously, if I detect something, I'll just go into screen share fairly quickly. So the white sticks, the vertical things that you see in Coast Guard stations and things, they're designed to detect signals from every direction. Beam aerials, which look like the point in the direction, these are more directional, but they work by focusing the big signal into a narrow beam, he says. So the gain you get is in that direction. So if you point it away, if you're pointing it in the wrong direction, you're not going to get the signal because it's not so sensitive when it's pointing the wrong way. So you've got to be pointing the right way. The other issue is the bandwidth. So I'll see if I can do this with my camera. If you get a dipole is really wide. Okay, so it can detect signals on this side and signals on that side. Okay, so once you get a beam, you start focusing one area, and the more elements, the tighter the beam gets. So the more and more elements, the narrower and narrower it gets, and it works a bit like a torch beam. So if you've got a really long aerial and you're just slightly off, you're not going to detect anything.
Yeah.
Whereas if you had a wider beam and you were slightly off, you'd still capture it because it's a wider beam width. Oh. Now, the advantage of a beam is that gain. So when you've got more gain, so it's a bit like my microphone. If I get focused into my microphone, obviously my voice goes up. If I get further away, it's getting less and less of a signal. But the advantage is, you're getting a signal from a broader area with an omnidirectional.
Oh, that's what.
If I put one of my other mics on, which is, a directional mic, again, if I just point it the wrong way, it's all.
Yeah.
So you're not hearing the word I'm saying. So you have to. So I've always used. Well, when I used to be doing it kind of reasonably seriously, I had both. So I had two receivers. So I had one on my beam and one on my omnidirectional, and then basically I had, because you can run multiple instances of Spectrum Labs. I mean, I've run like 5, on a decent PC or a laptop, you can run it 5 times. So I run Spectrum Lab on 5 different instances, and I had it scrolling at 5 different speeds. So at the slowest speed, it would go across the screen in an hour, and on the fastest screen, it will go across in a minute. So again, I could count the number of meteors in an hour, and I could, because that was a compressed display, I could just count little blips. But on the faster moving display, I could actually see more of the waveform. But again, if you get 2 aerials, you get the best of both worlds. Right. And I know for a fact, because I've done it, that the omnidirectional will pick up meteors that the directional beam hasn't seen, and vice versa. Because the beam's got more gain, it's picked up fainter meteors that the omnidirectional hasn't. So it's swings and roundabouts. But again, if you buy a swing and a roundabout, you get the best of both worlds, which is what I did.
If you've got like a TV aerial type of aerial, and you've got your horizontal part of the aerial, and at the back you've got your vertical part. If you enlarge that vertical part with chick wire, do you get a better reception?
It's much better. It's much better to design or copy it or build something, because there's gazillion of plans on the internet to build a proper aerial. And again, if you're handy with your hands, you can cut wood, and you can bend a bit of iron, and you can use screws and pliers. You can make your own aerial fairly easily.
I've got Ken's Sky at Night copy for the people to use.
Piece of wood, 3 bits of copper in some way, and that was it, done.
Yeah, but it's much easier it's much easier to actually start off for a blank bit of paper and make an aerial rather than modifying an existing aerial. Because if the aerial is not cut for that frequency, that means you're going to have to cut all the elements, because all the elements on a beam aerial, the distance between the elements and the length of the elements are related to the frequency. So you'd have to make all those modifications, which is a bit of a pain.
Yeah.
And again, all you need to do is, for most of them, is get a lump of aluminium, cut it up to length, mounted on a bit of inch by inch wood, and that's a kind of simple, basic aerial.
I'll just say,
Joe, a question, Joe, if you don't mind.
Yeah, John. I think John had just go ahead, John. We'll get you next, Chris.
Yeah, Ben, serious radio astronomers don't have teddy bears.
Is that right? Right, Chris. What was your question?
I missed the frequency of that grey station in France. What frequency did you say that was?
It is
143.049.
Yeah. Now I've got a white stick, and that would take that.
Yeah, that'll work.
Yeah. That
So,
would. Yeah.
Upper sideband. You need a sideband receiver.
Yeah.
And use upper sideband, and you'll hear the pings.
So I just put the software in, put the wires into my white stick, and into the software to that frequency, and I was just waiting for something that might happen.
Yeah. So basically, because for the people who don't know, Chris is another radio ham. So Chris will need to tune his radio to 143.049 upper sideband, and then connect an audio lead from his speaker output or a monitor output on his radio into the microphone on his PC, and then select the microphone input on the software, and then that's it. He's away. So if you've got one of these dongle things, what you would normally do is just select the dongle in the software, not the microphone, because obviously your audio is getting straight in via the USB.
And I would just wait, and if it was a big night and there's a lot of actions happening.
Yeah. The action is in the morning.
Well, it doesn't matter. If there's action, I would see that action happen on the scope.
Yeah. So if there's a shower, yes, you'll see stuff within a shower, but you'll see it every day. And I've always found 9 or 10 o'clock to be quite busy. So again, if you listen between 9 and 10 o'clock in the morning, you're going to see sporadic meteors, kind of when Graves is working. I mean, I haven't heard a single ping on this, and it's been on for a little while, and I haven't heard a squeak. So I suspect it's turned off at the moment.
Thank you.
Bit of it. Oh, I think that might be somebody else. Right. Well, I don't think there's anything else exciting. Anybody got any other questions?
Well, I'm going to buy a dongle just to keep me tinnitus switched off.
It does well.
It's been bad all week until tonight.
Yes. Yeah, you can't beat. Well, if you've got Mrs. Google or that other whatever it is version, Alexa, they've got white noise, which is a relaxing sound. So what you can do, I mean, occasionally I have ocean sounds or river sounds, but there's also white noise.
No.
And that basically, obviously, as you know, white sound, kind of disguises all the the roadworks and the neighbours with having a party and everything else. So that all works reasonably well.
Yeah, I'll have to give that a try.
Yeah, but certainly the modern way to do things is with dongles nowadays. But as I say, you've just got to be, if you're gonna go in for it a little bit, I would certainly buy one of the better ones. And if it's just something you want to mess on with, get a cheaper one and try it. But of course, as Ken rightly says, you've actually got to set up down the club. So you can always have a fiddle on it down there.
Well, I've got a Uniden desktop scanner with a.
Does it do sideband?
That's one thing I'm going to have to check on.
Yeah.
It does have about 3 or 4 different modes. But I'll have a look in the morning.
Yeah. Sideband is a bit of an unusual thing for radio, really, for scanners. Because most of them are, wide FM, FM, or AM, generally speaking.
Well, no, it's got 3 or 4 different modes on it. I mean, with the aerial I've got, it's just a little thing on the windowsill, right, and pick up the tower at Newcastle Airport.
Oh, yeah. Yeah.
It's pretty sensitive.
Yeah, I mean, I can wave to the guys from where I live. I can actually see the tower.
Colleton.
Yeah, well, funnily enough, I've actually I've had me LX200, and I've actually got pictures of the guys walking about in the tower, which was quite fun. But yes.
Just a daft question.
Yeah.
Normally you would put it on, say, a roof or a shed or something.
Yeah.
Would it work in a loft?
Yeah. Yeah, it'll work in a loft. It's just obviously you lose a little bit of sensitivity because your radio signal's got to fight through the tiles.
Mm-hmm.
But the other thing, again, it's a bit like fine tuning. So, for example, if you've got a beam aerial, sometimes you do better to lift the aerial up a few degrees, just to optimize it, because you've got to imagine
-10.
It's coming down. Well, again, you would. It's something that I've never done because I've never needed to.
The first one I had it in the loft, and I had it hung off string away from beams and all that.
Yeah,
it was good. Yeah, you got some hits, but when I bought a decent area, I put on me chimney. What a difference! They're like double the hits.
Well, that's right. So, I mean, essentially, if you again, try it by all means. Again, you've got the kit of the club, so again, you'll have a bit faff on. I mean, I find the software side quite interesting because, again, once you start messing about with the contrast, and again, these are all little fine adjustments, and again, you've got to kind of be into it a little bit. But when you, I'm trying to say this in a non-technical way, for example, if we're looking at planets, so example, if we take an image of a planet or a nebula or something, if we have the sensitivity too high, all we're going to see is white, and if it's too low, we're just going to see dark. But if we just get it right, we can see a lot of detail, and it's the same for the color. Again, if we get all that kind of balanced up, we can see much more detail. It's the same with setting up the visual nature of this in terms of the brightness and the contrast. And the other element is, I'll tell you, I'll just put my screen on here again. I'll just share the screen and I'll show you what I mean. The other element which I haven't shown is the, if you can see here, I'll just bring it up. Is this shows the range of sensitivity. So it'll display a weak signal from -120 dB up to 0 dB, which will be a very strong signal. But you can actually change this around. Oh, did you hear that?
Yeah.
That was one come in, but it hasn't appeared on my display. Let me just have a little look. I'm just going to get out of the 3D mode quickly. Get out. Apply. Right, let's just reduce this. Right, so I normally have this to, I'm just going to leave it on here for a little bit. I'll go back to that screen I was talking about. So this range of colours that you can see is reflected in this range of gain between 120 and 0 dB. Now, it's unlikely we're going to get a really strong signal that would go all the way down to 0 dB. Okay, so again, if I pull that plot screen, we're not going to get something which is going to leap off there, well, highly unlikely. We're going to get something which leaps off the display. But because we've got minus 120 and 0, we've got potentially 120 divisions of sensitivity that we can see. So if I turn that down to, say, 60, and you'll see what happens. So now we have a much narrower kind of range to show. So we have fewer steps to see. So even there, you can't really see the noise particularly well. Okay. That's probably about the best you're going to get it. Again, you should just be able to see the, oh, you probably can't see that. Can you see that or not?
Yeah.
Okay. So again, the software you can spend hours with. The other thing that you can do, as I mentioned, that Ken's got some software. If I just load it up here, some of the Meteor log software. And I'll just drag this up. So again, this is a little bit of, this is when people start going to sleep. But what you can do, and in fact, it might be easier if I pull up your watch window. Watch list. Okay. Now, if you can see this number here, this minus 42, 43. This is sampling between these frequencies, 800 hertz and 1200 hertz. So the software is scanning and listening for signals in that range. And this is the kind of noise level that's coming out. Now, when it gets a big signal, this goes down a long way, or if you like, or up a long way in terms of a plot. So it's detected a signal. So what you can do is write some code, and you can see, if you see a signal which is above, say, minus 50 dB, call that a meteor and then start to count. So while the signal is above 50, it'll start counting a variable, and then it'll give you a little bit of data which will say that meteor was so strong and it lasted for this long. And then it'll listen for the next meteor. And then those kind of things you can start to plot into a graph. Now, what I'll do, or what I'll try and do, is I'll just bring my browser up, and hopefully, just tell me if you can see my browser.
Yeah.
Yeah, so I'm just going to go to the RMob website. So this is the Radio Meteor bulletin page. Okay, so we're going to look at live observations. So we're going to zoom in on this map. So we'll just zoom into the UK. So these are people who are uploading data to the RMob website. So let's have a look at him. So let's zoom in on that. Now, can you see that okay? Let me just see if I can zoom in on my screen a bit further. So again, so this is kind of what the date is. What's the dates he's got there? August the 16th. So this is what you can do. So this is a guy in Belgium. So the most meteors he's seen at 8 o'clock was 128. Now, what you've got to be careful of, a lot of people haven't got a clue what they're doing on here. So what you've got to do is you're looking for curves on the display. So if they've got curves, like this is going up and then it's going down, they've usually got the system working reasonably well. Okay, so these all look quite good. Obviously that one with no data. But sometimes, you look down and you haven't configured the software correctly, and most people have getting, 6. So he's getting 233, he's getting 740, and this is all in the same time frame. 14, 98, and you'll find, you know, an average, especially if they're in the same kind of area. So that's the guy we're looking at, Philip Norton. So 36, would I believe that? Yeah, absolutely would. But if we look at this coloured graph here, okay, so this is dates. Now, who knows the date, young Mr. Harris? Or has he gone?
12th of August.
It's a
Right,
hit.
okay, so if you see here, this is the 15th. So you go back 14th, 13th, 12th. So you can see this area where it's red.
That's where the meteor shower was.
Yeah. So and of course, this will be the same for everybody, but as everybody else got that same kind of peak area. So anyway, so I quite trust his data. I think that looks about right for me. Now, this is the file that conditional software produces. So you can literally just go down the numbers and say, right, you've got some 40s, 60s, 65, 71. This seems to be a fairly, this is probably the highest number. Yeah, just looking around the data. So 53, 71, 54, 37. So you can see it started off at 29. You know, it's going up a bit, gets to 71, starts to drop off. So that's all believable. You know, the day before, it's peaking up the same kind of time. And of course, it's 1 o'clock in the morning. Sorry, 1 o'clock in the afternoon. So, oh, well, he's got no data for the, I guess he must turn it off at after 5 o'clock. So there's no data. But this is when it gets kind of quiet. So, so I would believe that. I would think that's set up reasonably well because he's shown the peaks as you would expect. And again, if you look at a quieter time, so if we looked at today, okay, so he's got in 1 hour, so that was at 5 o'clock. So you can see you only got 13. Is it the 16th today? Yes, it is. So he only seen 13 in an hour. So so there you go. And again, if you look for the low numbers, there's 6 in an hour. So that's 1 every 10 minutes, 5, 1 every 12 minutes, 4, 1 every quarter of an hour. So you can see how things change. But I mean, I've had in excess of 100 in an hour with my own setup, which I have to say was very well configured because I spent hours on the bloody thing making sure. Because what you don't want to do is when your next door neighbor turns the light on is for you to detect a meteor. So what you have to do is set the threshold just about right so you're minimizing interference, but you haven't set it to such a level where you can't pick anything up. But that's basically what you can produce. And again, the software is there. This software is called Color Lab, which basically, so that file, that file here is produced by those conditional actions. And again, you can download those from the British Astro site, which I've put on links on Facebook. And again, you just put your own parameters in, put your latitude and longitude in, and your radio equipment and so on. And then basically it's just FTPs, you know, in the background, that data up to the ARMOB website. And that's your data. That's what you produce, which is really quite cool. And this is the software. Again, well, obviously you can see Spectrum Lab. That's the Colorgram program. And again, you can get different packages for you to do this, to drive your SDRs. Okay, some people use different SDR software to produce this, but Spectrum Lab is by far the best, I think. And of course, it all integrates a treat.
can I ask you generally, are you watching your laptop screen, or you're putting it onto a monitor, and are you listening it over loudspeakers, or are you putting your earphones on?
Well, when this was a new thing to me, and I was working at home, I had a spare laptop, and all I would do is, or PC actually, and I just had it running in the background. So I was doing my work, and I had, you know, at low level in the background, low level noise. And basically, if I got a whistle, I turned around and look at it. But then, you know, after I'd done that for a wee while, I decided to use the software to do all the counting.
Yeah.
Because the other thing you can do is you can capture a picture of the meteor burning up. Okay, so you get that nice kind of image of the meteor, but you can also tell the software to record the sound of it as well. So I have hundreds of recordings, because what you can tell the software is, you know, because I'm not interested in the millions of sporadics, but I am interested in the big ones. So I just tell the software, if you see a big one, take a picture of it, so get a screenshot, and record its sound, and then save it. So again, you just tell the software to do that, and then when you get home from work or whatever, you know for a fact that if there's been 3 big meteors, you know, they're going to be saved for you in a file, and then you just look at them and then go, wow, yes, that's brilliant. So again, you can use the software to actually do some of the work for you. But some of the, you know, the interesting stuff is when you're doing it live. So especially for the showers, you don't know what you're going to get, you know, which makes it kind of interesting.
Right. Okay. Can we go back then? Because if you're taking an image, and let's just say it's a Percy shower, and you're pointing your camera up to east, northeast, you've got your you're getting a beep, but that beep mightn't be one that you can actually get an image of, or would you get an image anywhere?
Well, the image is of the sound. So you're not actually taking an image of the meteor burning
Right.
up.
Now I see what you're saying. That right makes sense now. Yeah, yeah.
Yeah. So there's people who do it visually, and there's several groups set up, and they're all over the world, that have wide-angle cameras set up in particular directions. They have 2 or 3, I think it's 3 cameras, so they have almost like a 360 view.
Right.
Then they have a piece of software which is calibrated very precisely to time. And then basically, if there's a meteor burns up between a number of different cameras, they can actually work out the direction the meteor came from and actually reproduce its tracking things. I mean, it, you know, works with NASA and various other things. So it's all like, you know, really clever stuff, but that's for like visual images. And again, you just buy 3 cameras and or 1 camera, and away you go. You know, you can use all sky cameras and all kinds of things.
All sky camera, yeah.
But that's the visual side rather than the radio side. So it just depends on what you can do. Or as
He's one I made earlier.
Or as David said earlier, you know, you just get the hosepipe out and wash them off your roof and pick them up with a magnet.
I keep meaning to do that. Get a big strong magnet and put it on the drain pipe.
Yeah. So it's entirely up to you which way you want to go down that route.
I once saw, well, I heard a meteor and then looked up and saw it. It was like skis on ice. Like, I was walking up the local shop about 9 o'clock one night in December. I heard the noise. I thought it was a skyrocket, but when I saw it, it was coming down, not up.
Yeah.
So I reckon somewhere in the fields west of me, there must be a meteorite.
Yeah, you just got to go and find it. Let me just have a look. Right, where's everybody gone?
We might cut out soon.
I think we've had a bit of attrition. Sure.
Yes, absolutely. Well, it's been. Well, I've got no idea what time it is. 9 o'clock. So you've all,
Yeah.
you've all done well to stay awake.
Yeah.
Really low power.
For this thrilling and exciting talk.
Interesting.
Well, on behalf of the society, thanks very much for your talk. This was the inaugural one, and
Absolutely brilliant.
we'll have them every month from now on, I think,
yes.
until we get back in.
Indeed. Well, thank you for all the interesting questions.
Next year.
Yes, thank you, Joe. You now learned something there.
Yes, thank you. Indeed.
Yeah,
Right, then.
Thank you.
No worries. We shall see you later.
Yes, Joe. Thanks a lot.
Bye,
Okay.
Joe.
Catch you later. Bye.
Good night, everyone.
Brilliant.
Bye.
Good night.